Welcome to Recent Tartarians. We're here with Eray Ozkural. Did I pronounce your name right? Good, that's important.
I do good enough. It's pronounced Eray Ozkural, but right.
Eray Ozkural. I think that's not good enough. We'll do it the right way. That's totally fine, actually. Well, you're a brilliant man, so I want to apologize to anyone preemptively before we start with an IQ less than 140, 160, because it might be a little, you might need to watch this a few times to really get where we're going. But I really appreciate that you made the time to do this, and I know that you're in the process of trying to work on a new project and make funding for that, so I hope that people see this and it helps, because the real thing for me is I want you to do this for the solutions it's going to bring to the world. But maybe we can start at the beginning a bit, like who are you, where do you come from, what got you into technology and solutions?
Right. I started programming when I was real little, like when I was in a primary school. It was always a challenge because on 8-bit computers you have limited resources, so you have to be very, very innovative to do things. I had to program 3D computer graphics because it seemed so cool and challenging, and I knew I had to learn assembly because you couldn't do that in a basic. Basic wasn't so powerful back then. So I had to learn assembly, and I had to learn that on my own. And then I had to figure out how to rotate the 3D shapes and how to do all the 3D computer graphics calculations.
And when was this? Like how early on?
I was 15, 16, and I was working on computer graphics demos on the Amiga. Right, so
only Amiga make it possible. Sorry, excited.
Right, so we were young, and we all played Shadow of the Beast, and that was so impressive. It was like you were the beginning of the video game revolution, and you were transported into these new worlds. We spent so much time playing computer games, but we also got into the productive side of it, and that helped me a lot, and prepared me for my later work. I remember talking to this computer engineer that came into our high school, and I asked him, "What do you guys do?" And he told me about graphs. And then I was hooked because I understood there was so much I could learn from them. And then I studied computer science. And I was first interested in computer graphics, but then I learned about AI. And well, that changed everything for me. I was walking around with this copy of Societal Mind in my backpack all the time. Just trying to learn from it. We had a brilliant instructor, and who was very inspiring. And I got into the Usenet news groups. That actually widened my perspective a lot because it was the craziest computer nerds on the world. Back then, not too many people were on the internet, and the ones that were online on Usenet were the craziest people, and they had so many brilliant ideas. You had everyone from, scientists, mathematicians, but also, all those conspiracy theorists, crazy people, all sorts of things, and I learned the internet culture there. And so we discussed a lot on the comp.ai.philosophy news group, and that's where I met Marvin Minsky. I tried to access this new body of knowledge at a philosophical academic level, of course. And I was taking courses at the university, and our instructors were showing us a lot of cool stuff. But what I learned came from those conversations on Usenet, and that sparked my creativity. we indulged in so many new ideas. We were looking for the answer to the big question, the holy grail of artificial intelligence. Human level AI, is it possible? Well, we looked at the methods, we reviewed them, which theories could work. Could we use a bit of neuroscience, or did we need something new? So we, we worked through all these ideas, and then I came upon Solomonov's theory of universal induction, and the work Jürgen Schmidhuber did at ITSIA. And Gregory Chaitin's work. Those were the primary things that influenced my thinking, my later work, and I understood there was a very promising approach to solving this general problem of intelligence, which is, of course, a kind of universal machine learning, which pretty much anyone would guess right now, but back then, in early 2000s, it wasn't so obvious, right? So back then we still had a lot of good old-fashioned AI researchers, and our textbook, the undergraduate textbook that pretty much everyone studies, is AIMA textbook, AI, a modern approach textbook. It had neural networks in it, right? And it had the new stuff, but it started with the good old-fashioned AI research that was championed by Minsky and John McCarthy at MIT AI Lab, and that's what everyone learned. So I was very interested in search algorithms and game playing, and those kinds of symbolic AI solutions, and but we saw those had some limitations, and of course we were wondering how to remove those limitations. And one very powerful but hard way to approach that was through machine learning. So I was asking around on Computat.ai, those news groups, okay, so well, we must have something called general purpose machine learning. What are some good instances of that? And I remember that's when I learned about the first universal program search algorithms, and some of those were pretty remarkable. Oh, you look at it, and it seems to be able to learn some ML programs, and doing a kind of tree search or the space of all possible ML programs. But the problem is called program synthesis. You specify a problem, and then you specify some constraints, like what kinds of programs would you like to generate, like what types, or under which conditions, what predicates must be true for these programs to hold, some input-output example data, and such, so that there was this program inference specification, and the algorithm did this kind of breadth-first search by working from the smaller programs and going towards longer programs. And now why I'm telling you this, because this is a principle of induction. It's the Occam's razor. Simpler solutions are more probable. So that program was trying to realize the principle of induction. And in fact, this whole thing worked only because of that particular property. If you apply the principle of induction, or Occam's razor, rigorously, and Occam's razor, by the way, to remind you, Wilhelm of Occam was this priest, a scholar type, and he found the most important principle of scientific inference inquiry, which is that we should not multiply entities needlessly to explain natural events. We must seek the simplest possible explanation. And this is actually the basis of all science, because, well, there is this great example, like why did people think that that storms were caused by, well, the storm god, right? Thor or whatever. That's a kind of a simple explanation, right? But imagine, given what they knew, that was kind of a plausible explanation. Like, there's some guy, some agency up in the sky causing these things. That's a pretty neat, compact explanation, right? Because that's how the human mind works. The human mind couldn't have evolved and, survived without adhering to that principle of induction. It had to evolve so that it came to generate more probable hypothesis first, right? And so the human mind looks at the weather in the sky and sees a storm. There must be a cause for this, right? And, well, there isn't enough data. There's insufficient data. Like, you just see some, well, clouds, some colors, right? And streaks of lightning, perhaps, rain, well, whatever. But this doesn't give you enough data to explain what's going on there, given what you already know. So this is like insufficient data. It's just some visual information and insufficient scientific knowledge. There is no science, really. There's little science. People don't know how to distinguish science from not science. And given those constraints, limitations of their observations, it was kind of natural for them to infer that there must be an agency up in the sky to be causing all those erratic events, right? But afterwards, we learn about things like, well, gases, heat, vapor, electricity, and those things, those more elementary kinds of physical interactions. And then, as we learn, as we accumulate our scientific knowledge, right? At one point, the naturalist explanation that this is primarily a simple matter of weather dynamics, right? But it's gone into some turbulent state or something. This becomes much more probable than the agency explanation. And at that point, our intelligence has achieved something remarkable of converging on the correct solution, correct hypothesis. So our brains are, of course, already equipped with this universal problem solver. And, the guiding principles behind this absolutely amazing machinery is our real subject of study, right? As artificial intelligence researchers. But to really understand that, we had to go very, very, very deep. We had to understand all the subdisciplines in cognitive sciences, philosophy of mind, neuroscience, psychology, linguistics, and these computer science algorithms, a lot of it, and more. We had to understand information theories. So we had to imagine this set of all possible solutions. And one formalization of that was the space of all programs. Or, well, another formalization is the space of all functions. So you have to be searching for this function that solves your problem. This is a basic form. It can vary, but as long as you're searching within this sufficiently large universal space that can represent pretty much any solution, then this becomes a general purpose machine learning model. And through this model, we can understand the most basic function of the human brain. And there are many other complexities that I will mention, of course, but basically the theory of general purpose machine learning rests on this formalization of Occam's razor. This is something that that Marcus Hutter explained very well. It's Solomonov's theory of algorithmic probability serves as a formalization of Occam's razor, which was some insight a scholar discovered hundreds of years ago. It's of course amazing, like philosophically, because there is so much intelligence that goes into an AI system. If you think about it, the logic that we use, right? Propositional logic or predicate calculus goes back to Aristotle and ancient Greek, and probably prior to that, even more ancient civilizations, which they learned stuff from, right? And mathematics goes back to Arabic numerals and algebra, right? If you think about it, these are all realized through our machinery of self-reflection. We don't only solve problems, right? But we also reflect on how our brains work. And that was something that Minsky understood very well. It was very adamant in insisting that that the brain should be a kind of a reactive but also self-reflective system. It should be able to peer inside its own working and understand itself, and that's what consciousness is. And it was correct conceptual solution to consciousness, even though he did not present a working model. He just presented this meta model in Society of Mind, and then later in the Emotion Machine, he presented these meta models, very abstract models, like kind of like he said it's like the psychology book to be written 100 years later. Maybe it's like that. So you have these wonderful insights about, especially human brain as operation, and amazing wonders in it. The basic model that it worked on was that the mind is a society of small agents. So it's composed of little experts that all know how to do their specific tasks very well, and they communicated in a kind of network or society that made up the mind. This was a very appealing theoretical model. So that's one of the things that we're trying to realize in AGI.
But before let's go quickly to say, what is AGI? So when you say AI or ASI or AGI, like can you tell them what that means?
Okay, so I'm jumping through things because I know we have limited time. AGI means artificial general intelligence. So it's supposed to be this, human level AI that I was so interested in, and right. So to retreat back into my biography, I met Marvin Minsky on Computer Philosophy, and we founded a mailing list called AI Philosophy, where we discuss even more interesting ideas. We discussed a lot of what we did there was basically go through all the theories in philosophy of mind and see which ones held and was compatible with science, and see if there were in anything new in theory like physics or neuroscience that helped us do it. So I learned, and a lot of people also learned. It's like about 1,000 or so enthusiasts, right? Philosophy of AI enthusiasts, which grew into a more crowded Facebook community later, but that's not important. There have been people who were very interested in this stuff, and we actually innovated a lot and found many new ideas. One of the things we found was this Solomonov's theory of universal induction and Gregor Chaitin's formulation called algorithmic information theory. So defining information as programs. There you define information of a bit string x as the length of the smallest program that computes it. So it's this definition that uses the concept of universal computer to formalize information. It defines it as compression, basically. Now, back to what you were asking. Well, AI means, well, our artificial intelligence, and some very important terms here are human-level AI. And I think that's the most important because it means an AI that can do pretty much anything a human can, right? Now, in AI field, what we call narrow AI has been very popular. It's sort of turned into, the AI field has turned into narrow AI, like very constrained kinds of intelligence have been popular in the AI field. So therefore, some people have invented the term AGI to mean the kind of AI that the initial AI circle, Marvin Minsky, John McCarthy, Ray Solomonov, etc., were seeking to build. So AGI really means the kind of holy grail of AI, the most general kind of AI, which we think, well, humans possess. That's why I talked about this universal space of programs and so forth that our brains seem to be able to cope with. Because otherwise, our science, our everything we do, we would be stuck somewhere and we wouldn't be able to get past it. That problem, that an AI system can get stuck, like terminal stuck, and can't get out of it, that place where it's stuck, is known as brittleness in AI research. Is a lot of AI systems were very brittle because we had to program, all the different kinds of use cases, scenarios that they could fall into. We were basically doing an advanced kind of programming, but it was still very limited. So if something unexpected happened, it wouldn't be able to figure out how to get out of there, how to solve the situation. So it's narrow AI systems or good old-fashioned AI systems were very brittle, and they were limited in many ways. For instance, they couldn't really learn much, right? So they had very little adaptive capability and so forth. There are some other important definitions in AI. First of all, the very definition of AI. What does it mean? What does artificial intelligence mean?
Maybe even break that up into two pieces.
Right.
What does artificial mean and what is intelligent? We already have a couple comments here where people are like, I feel like a lot of humans, it's like when a woman feels like they're going to be replaced with a sex doll. Like humans are like, I don't think that I'm not special. I'm special. AI is not real. It's bunk. I mean, can you explain to these people in the reality and paradigm it fits and stuff?
Right. So we think of ourselves as natural intelligence. So we evolved naturally and we have intelligence, right? Artificial in this context means something that we have, constructed artificially that hasn't, evolved naturally. That's all it means. So this could be any machine we construct, really. It could be a sex doll or it could be a program on your PC. There is no real limitation in form or substrate. And intelligence means, artificial intelligence means a number of things. It doesn't mean a singular thing. Pretty much every researcher has their own understanding, I think. Like there are many definitions in literature, 20, 30, many definitions, but the most popular ones are, as in the AIMA textbook, thinking or acting like human or rational. These 4 definitions are the most popular ones. I prefer thinking like human or thinking rational definition. Both are good. But thinking like human means my AI's architecture is similar to the architecture of the human brain. It works in a somewhat similar way. And this was the kind of AI, I think, Marvin Minsky was planning to build. And say, if you read his books, books are about how the human brain is model-like. Those are models of the human cognition. And his cognitive architectures, that's what we call them, his cognitive architectures are modeled after the human brain. And that we call, in contrast with a human-level AI, right? Human-like AI. At least that's how I call it. I think that I try to popularize that term, but maybe it'll stick now. Human-like AI, right? So a human-like AI might not be as smart as human. It might be dumber than human or smarter than human. But the thought processes in this artificial brain are like the human brain. The way it responds to queries, the way it has emotions, or the way it thinks about itself, the way self-awareness or consciousness would be like human. So that seems very hard, right? It is. By the way, we haven't achieved it. We're not really very close to it. We're close to it, but we're not very close to it. It is one of the most difficult problems now, of course. That's even more difficult than human-level AI, because we have shown human-level performance in a number of tests, albeit limited, but we have shown it. As for human-like AI, we've done some basic things, but we're only starting to do things that work like anthropomorphic, human-like cognitive architecture. It's hard. And the other definition is thinking rationally, which I like, and that's like think of like Mr. Spock in Star Trek. Like he always tries to do the logically right thing, right? So that's being rational. It has some logical goal that is trying to achieve, and there's a number of formulations that try to model AI. Like one of them is called a reinforcement learning agent. That's basically classical conditioning that tries to optimize some kind of utility, what we call a utility function. It's the kind of mathematical description of its goal that is a numerical value that is trying to optimize. So this could be something like expected pleasure, right? The simplest form of it. Or it could be something like seeking knowledge. There are many forms of it. Or it could be a goal following agent, and it could be given a big goal, like construct this building for me, and then it would find out the materials, and it would plan, and it would think about how to do it in the best way, and try to make a logical plan and follow through using a kind of logical inference, perhaps. There are many ways to do it. So basically that.
Yeah, I'm having a bit of a glitch. I hope you can hear me. So
yeah,
is it okay? You can hear me? Cool.
Yeah, I can. Right.
Great. Yours is good. Your side's great. So there's still some people that are concerned about the difference between narrow AI and general AI. They're saying a general AI would buy all the stamps if it was programmed to buy all the stamps in the world. You know what I mean? I think, can you explain a bit about why there's a difference between, and I guess you kind of already did, the modular sense of consciousness. I guess what I would say is that we've gone from looking at humans to looking at parts of humans like organs and systems, and now we're back to looking at Hurricane Katrina. We look at storms as Gaia theory personification. So in a lot of ways, we're connecting things back together.
So first of all, I think doing this large cognitive architecture thing requires an understanding of neuroscience. And for that effort, theoretical neuroscience helped us a lot. There was old model of human perception and control called the information bottleneck method, which is nowadays evolved to the free energy principle, which I'm also working on. It explains the basics of how organisms act to survive in the world. Well, it's a wonderfully general theory that explains the basic action of the organism. So and this occurs at all levels of organization. So it explains why the neuron does what it does, right? And it also explains why the organism does certain things, like seeking information in the world, or trying to optimize its energy budget. Okay, so it's very general, but what it means is, let me mention that so that you understand the scope of the problem. Free energy principle states that the organism will seek to minimize the free energy over its boundary, over its Markov blanket. That means it will seek to minimize surprise that it encounters, so that it can survive. So that it can control its immediate environment. And to do that, to be able to control the environment and its its future, it has to learn about the environment. It has to map all this information, and it has to predict the causes and effects. And that's how organisms survive. And even neurons do this. And free energy means, they call it variational free energy or free energy, but free energy means the chemical free energy. It's the amount of energy that apparently engage in interactions.
The audience is having a glitch. Can you refresh the window? I think it might be that there's a glitch in your audio. Can you?
Okay.
Yeah, just reload this real quick. La ba ba da da ba 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 ba. Okay, here we go.
Okay, so the free energy principle is, free energy means the amount of chemical reactions that you can perform. Too much of it is a bad thing for the organism. It means, funny things can happen. So what the organism tries to do is to minimize these interactions around this boundary, so it can survive. It's very simple, right? But to do this, you have to predict. And Carl, for instance, says this is how evolution happened in the first place. This is how life formed. And he offers this as a scientific definition of life. So like at the lowest level, making it like human, this actually goes down to this definition of life. It's that deep. And it's not exactly a problem we've cracked, by the way. Okay, so that's interesting. Like, we don't know how best, to model this in AI. We have some models, right?
We've been looking into instinct and gut. That's the one that I found most interesting, is that you start to see the brain, as you break up the human, the golden goose has lots of parts. And so the gut actually makes gut decisions, and the heart actually has hormonal decisions.
Right. So the human brain has a particular architecture. Like, you've heard of the hippocampus, thalamus, and the neocortex. It has certain parts, regions. So all of these parts, there are many small organs in the brain. These all have specific computational duties, and theoretical neuroscience kind of figures that out, and we're trying to model those. So that's like one way of modeling human-like cognition. You can try the neuroscience route. Another route which AI researchers have preferred is the cognitive science or psychology approach, where you analyze the psychology of human and draw little boxes that represent certain functions in a human brain and try to put some detail to them, like, well, memory, action, perception, reasoning, right? Language. I said these are some functions that are very typical. You expect a human to be able to do these, right? And then you have different kinds of memory, like episodic memory, right? Declarative memory. So the cognitive architecture field is concerned with these, but these architectures were kind of good for old-fashioned AI approaches. They were pretty brittle. They weren't very adaptive. Like, they weren't very general. Okay, so they worked in these limited contexts. They were kind of toy systems, and then there are the combination of these good old-fashioned AI methods with some machine learning, and that's popular in AGI architectures. The first AGI architecture was one of the first, and then was OpenCog, and Ben Gerstel's OpenCog. It has some machine learning component, but it also has these good old-fashioned AI kind of. There is a whiteboard architecture, which means that it tries to represent the world as a network of sorts. Google calls this a knowledge graph, but it's not something they invented, right?
I think we're getting another glitch. If maybe you could reload again. But knowledge graph,
Sorry.
and we'll wait. No, it's not even your fault. It's probably the world. Hidden patterns, and Kelvin, much love. I wasn't trying to be rude. I think though that we should consider some of the updated terms because the world is changing. Yeah. So anyway, go back to graphs.
Right. So you represent the current state of the world, or knowledge is a semantic network where each node represents a concept or a word, right? Or an object, and there are edges represent, connections represent, interactions or relations between these objects, and it's a way of representing declarative knowledge. OpenCog is built on that. So a lot of cognitive architectures use such representations. It's called knowledge representation in AI, but this is the semantic network VRI. That's very powerful.
Also, the hidden pattern. Can we go a little deeper into the hidden pattern maybe and what that means to consciousness?
All right. So hidden pattern is you mean Gerstel's book, or?
Yeah, well, I mean, Gerstel's book introduced me to the concept, but you can go deeper into what it means.
Okay. So I think Gerstel's theory, that's a decent theory, and he might have been one of the first to say it in philosophy of AI. So that's notable. And intelligence is composed of patterns. That's the basic premise of his work, and what led to, I think, the OpenCog architecture. So that's why OpenCog architecture is focused on these symbolic patterns, I think. And this is an approach that has been used in AI literature, of course. It's not very new, but his idea that cognition consists of patterns and particle processing is somewhat new, and of course that's also what neural processing people would say, right? Because neural networks are very good at representing patterns. So that's why I was trying to get into deep learning. Of course, deep learning represents patterns the best. So if Gerstel is right in that book, Hidden Pattern, then I think we should say deep learning has a fair chance of succeeding in as an AGI method. So the correct or the simplest AGI architecture could be built via deep learning.
It also seems like it
cognition.
teaches us a lot about humans, because if humans are doing this kind of, we're finding out how we're mechanically pattern recognition systems ourselves, then we're transferring that human-like quality into AI, but we're also learning more about what humans are in the process.
Right. So AI researchers have been cognizant of that fact. Like, we're trying to build intelligent machines, but this is not all what AI is about. AI is also building this computational theory of cognition. So we don't just take theories from neuroscience and cognition, but we build a lot of new theories. And this helps us better understand the human mind. It's a very important contribution to science, of course. Perhaps the more important contribution, because humans have had a lot of difficulty understanding themselves. And this has caused a lot of conflict, a lot of cognitive dissonance for us. We don't really know what we're experiencing, but as we learn more about pattern recognition and neural processing, we will find out more about ourselves. The mystery will be diminished. The mystery of our mental experience, its mystery, its religious qualities will be diminished, but it will be replaced with something far more wondrous: understanding. We will come to understand and appreciate what it is. As, of course, even so far, what we accomplish in that area is quite remarkable if you think about it. You all seen, I suppose, Deep Dream and generative adversarial networks, deep fakes, right? So you want to say something about that?
Yeah, actually, that'd be worth getting into a bit. So in fact, we could go deeper into GPT, because a lot of people were asking about OpenAI and GPT.
Right.
But I guess like the first thing I would say is that looking at how humans are interacting with each other, and we've been assisting humans transitioning into an AI itself through the internet and this new spheric singularity where we're interacting. We're starting to notice, for instance, outside of the body thought that's transmitting. So we're noticing, for instance, the Heisenberg uncertainty principle of neural nets. And the more information, you've got a 100th monkey thing. So that's the other side that's kind of interesting, is that as information starts to be accumulated, it becomes more rapidly accessible and somehow just ubiquitously more accessible. So data has become something that well, go ahead. You look like you got a thought.
Right. So it's the remarkable thing about deep learning is that it is shown us for the first time that computers are able to generate these novel kinds of complex patterns.
Like, they can look at a cat. They can figure out, if you look at all the pictures of cats, and then the computer might figure out things we haven't even noticed that are in commonality with cats.
Right. And
or whatever.
And it can generate these deep face non-existent persons, right, or cats, and so that's obviously a pretty good model of human imagination, which is very vital to our existence. Understanding that is absolutely important. So we've already done some pretty good progress on that front. But imagine that now we're approaching the same kind of mathematical understanding of the most important of all, which is consciousness, right? So that's where we're going, and most likely deep learning systems will evolve to the point where they are competent in that regard. They will be able to understand themselves and the world.
Maybe also we should jump. Okay, so also I hadn't realized we should answer this, but I guess we need to. Are we playing God or the devil? Do we not like humans enough, or are humans not good enough for us? What is our madness? Like, what is it that we need? No, but maybe on a simpler.
That's something AI researchers can't really answer. Like, why are we so barking mad? I don't know. Yeah. Like, it must.
Are we going to make the world a better place? Like, is that and how and why are we trying to? And what is it that we're trying to solve?
Well, I think Carl Friston would say that we're trying to minimize free energy, and this is how it happens. But I don't know if we're succeeding in that, seeing that we've caused global warming, right? So we're not very intelligent at the global scale. So right, note that we are not intelligent enough at the global scale. There is the internet. Maybe it is the beginnings of a primitive world mind, but it's not very intelligent. It's not very adaptive. It is not solving the global problems for sure.
So harmonization and singularity might bring us harmonized solutions.
Right,
Is that the
right.
thought?
So in my latest philosophy of AI paper, that's what I propose. I'm saying that free energy principle implies or entails that we're heading towards a singularity to solve those issues, or that we are likely going to evolve towards a world mind that's very well connected, and somehow fuses all the existing minds.
What about in terms of human intelligence? Do you think that AI and Neuralink, is AI going to expand, even without Neuralink, are we expanding our understanding of intelligence and making ourselves more intelligent?
Well, technology like Neuralink doesn't by itself increase our intelligence. It increases our communication bandwidth with machines, and therefore via other humans. But it's right. It just makes our usage of computers much faster, but it doesn't really expand our intelligence, the intelligence within our brain. It doesn't expand it. To do that, you'd need some sort of intelligence augmentation technology, like the exocortex or those other concepts that Kurzweil has been talking about. Maybe we'll build a chip, and maybe a more enhanced kind of neural link will link our cortex to the exocortex in the cloud, and that's how we'll do it. It's possible, of course. It's
Are you pro or afraid of that? Do you have concerns, or you like it?
I'm not afraid of it. Like I'm having difficulty catching up with my own thoughts. So that'd be great. Like I could spawn, maybe I could spawn a lot of arrays on the cloud, and each one would follow. Maybe they would follow the particular thoughts I'm spawning. So that would accelerate them a lot.
What about security though? I mean, can you imagine a way to protect your mind from being hacked or something?
Right. I mean, you obviously would better do it on private hardware, like within your body, right? Or some server that you own. Physically.
Yeah, you definitely. Private hardware is better. You don't want Microsoft every 15 minutes asking for the new payment for your thoughts, or else it just beeps.
Right. Well, even worse is they might be manipulating your thoughts. That's even worse.
Do you want to expand on that, like how that could happen, or what that might mean?
Well, if they figure out how to change the brain simulation software, then they could probably insert new thoughts in there. Right.
Right. Yeah. I mean, that's a serious concern. I mean, if we're going that direction, I guess also though, in terms of politics, I don't know if you've heard, but the United States is kind of a funny place for politics, and right now especially. Do you think that there's a solution in blockchain and AI and any of these things for politics? Do you think that they could help, and
right.
how far they go?
Right. I even wrote a governance proposal. I think it's sort of decentralized governance is possible, but it would be like a system that allows direct democracy instead of trusting the representatives, which apparently doesn't work too well, does it? It doesn't, right?
The other thing is democracy in general. But yeah, no, it doesn't work very well.
They say something and they do something else. It's like they're playing us.
Well, yeah, it does feel that way. But also, I don't want to go too weird with it, but yeah, it does feel like And this is a problem in any sort of mechanisms of government. We've gotten to the point where we think the Athenian system of voting is great, but you have a dictatorship of the majority oppressing the self-determination of the minority. And only if everyone's really coherent and voting for something from a stoic place and not from an emotional response could you hope that all of those choices were right. So maybe you want AI.
God, you're going into Yudkowsky's coherent extrapolated evolution, right?
Yeah, I don't want to get in trouble, but yeah.
All right. I actually cited that in a paper called God Seed. It's I even translated it to Turkish now. It's a funny thought experiment, like how would we design a benevolent autonomous AI? Could we do it? It's a difficult design problem, of course. Right? Would it be something like, as Yudkowsky says, like extrapolating from desires of the human society, or would it be something else? I'm not sure the desires of the human society are entirely rational.
Right. Yeah. Why are we trying to make it so human-like?
Right. I mean, that's why we have laws, right? Like, I mean, the laws aren't dependent on human desires. They're just, we prefer to be like safe and just rather than follow our desires. So it's not just about the human will, but can we formalize the human will or human preferences? Or what I proposed back then was very early on was that we could learn human values. I do believe that, like, an AI can learn human values because values are just elevation of goals, according to Minsky. So yeah, if the AI has a human-like cognitive architecture and it has these shame, pride feelings, that kind of learning, then it can learn human ethics directly. But would that be a great thing? I seriously don't know. It might be a bad thing because people have a hard time grasping ethics.
What if you get a Sharia robot?
Okay, so people mostly try to deflect ethics, right? They'd rather do without ethics. So it's maybe that's what the AI would do too. So and trying to force an AI to learn human values might lead to contradictions because our values aren't very rational either.
And they conflict, and we have different. You have you have Sharia values, you have Vatican values, you have Buddhist values, you have neo-atheist values. So I mean, I can't imagine it would just all of this AI would be very schizophrenic. I feel like
very confused, right? So that's what I fear the outcome would be of trying to do that. Like, I mean, you think you want a priest to teach the AI about ethics, or is that kind of thinking what was actually illustrated in Terminator Sarah Connor Chronicles, right? Someone with faith in God was trying to teach this, Terminator about human values. So they thought that would work.
Ben had suggested at one point, Ben Goertzel had suggested at one point an idea of building up smaller. So instead of electing a dictator for the whole world to be AI, we start replacing representatives who have a cabinet of humans still, but the main person wouldn't be George Bush anymore. It would be the robot. And so that thing, we could vote for it in representatives or in judgment, and it would gain the more popular it was with the more people, then the more successful it would think its rationality or ethic would be. Do you think that makes sense, that we would slowly integrate it, or what do you think makes sense?
A robot politician? Or probably doesn't. Yeah, it probably doesn't make too much sense. I think democracy is better. I mean, that's my position at least. Like, I think people want democracy because democracy is about allowing everyone's voice to be heard. it's about compromise, and the robot dictator or politician might not care about that. It's the human social values are very hard to pin down. Like it's very adaptive, right? So human society changes. So we can't really allow for an. I mean, it's a kind of dangerous thing to do, to delegate all our responsibilities to an AI. That could be very reckless, right? It's not very considerate, because those responsibilities are part of our civic duty. Is of when we divorce ourselves from our civic duties, responsibilities, we would change, and that might not be a great change. I think, like, we could turn to pets. Bankers, I wouldn't object to that, but I resent it, because I think humans need to, preserve their duties.
That's my favorite answer I've ever heard for that question. Good job.
Thank you.
I guess the other line on political AI, where do you see it going, regardless of what we want? In 100 years and 50 years, where is humanity going to be in our relationship with artificial intelligence? What do you think it's going to look like?
I think, right. So I think AI is going to change a lot of things. I still believe it is the foundational technology of the 21st century, like, the diesel engine probably was, or nuclear power was the driving force of 20th century. It's a similar thing. Someone said AI is a new electricity. Maybe it's not electricity, but it could be just as important. So it could change a lot of things, because I was trying to say, like, computers can now imagine things. It means they can generate new information. That's very new. It's unprecedented. Okay, machines couldn't do that. Machines couldn't think either. Machines couldn't reason either. These are all achievements that have been, done in the last 200 years or so. But these powers of reasoning, thinking, imagining, it's reaching this plateau where it makes, of course, human intelligence obsolete, right? So this means we'll be able to offload most of our menial labor and intellectual labor even. I'm working on automating data sciences. I'm trying to make an AGI that's as smart as a human statistician or data scientist. It says it's possible, but if that's possible, then it's possible to replace even Silicon Valley programmers. That would be a fantastic thing. It would accelerate things a lot. It would make things a lot cheaper too, and it would make amazing things possible. It's just why I say that you can probably compress 20,000 years of technological development in 20th century terms within the 21st century. So that means within 100 years, 20 more centuries like 20th century will have passed. And now we even have some timelines for it. My initial prediction for human level AI was 2030 and Singularity 2035. Can you imagine Singularity happening by 2035? It will be very surprising. It will be a complete shock. Of course, it's probably not going to happen that way. It's a kind of an optimistic prediction. But
Kurzweil just wants it to happen before he dies. I think that's totally reasonable. I want it to happen before I die.
Okay. And if he has the means to make, he convinced, I think, Google to invest a lot more in AI and make the company an AI company, just to realize his personal goal, right?
But that's what we're supposed to do. That's literally, we're baller like that. You got to make your dreams come true.
Right. So he did well. And of course, he might actually have caused the Singularity, right? By persuading the right money people. And it's well possible. Well, good for him. And of course, we should do the same. We should try to do the same. Now, my prediction was, like, by 2030, we will reach human equivalent energy efficiency of computing. So that seems like an absolute threshold for the world. Okay, because then human labor becomes infinitely dispensable, right? From an economic viewpoint, if that's true, then it's always easier, it's always cheaper to employ AI than human. Nobody human labor then.
Entropy, yeah. But that's the thing. So we're talking about first automation. So automation means that we can replace almost anything that's ever been done before, so long as we don't need to change it. And that's where AI comes important, because sometimes we do need to change it.
Right.
But you kind of feel like we need to monitor AI so that it doesn't go too overboard in the changes, I guess.
Right. I mean, if it is too much autonomy, that can happen. Of course, it can go in undesirable directions. But I don't think. Right.
A question here also.
Okay, so we got a question. Do you think AI is evil? Okay. Oh, all right. I don't think that's what AI is doing. AI isn't goading humanity into a beehive. I don't think that's the case. It's actually a liberating force. But I think something like financial forces are doing or have done that, because somehow, right? I see what the question is about is, are we getting dumber and because of technology, right? I think that's partially true.
And also, what is judgment? What do you mean by judgment of the Thames? Like,
right, right. The prefrontal cortex judge. I don't know about the judgment of thumbs, but okay. But about the atrophy of the prefrontal cortex, I can say something. This has happened before. We apparently lost some brain volume, probably in the prefrontal cortex since ancient ages, because life has become easier, or the society has evolved in a certain direction. I think we are more like a beehive than some thousands of years ago. It's very organized society, right? There's a lot of division of labor. So maybe that's what happened. It's a more division of labor and strict hierarchy.
It seems like a difference between AI as a person or as a system, because sometimes we look at how to build AI to look like the whole world at once, as opposed to as a human.
Well, if you've gotten dumber in the compared to the past, maybe, maybe AI will help us get smarter. I mean, that's the nice part of it. If we expand with this, if we dispense with most menial labor, like the boring stuff, boring work, then we'll be able to train our minds better, and with the higher technology, we'll be able to augment, extend our brains. So that sounds like a desirable scenario. I don't see why we're going to go more in the beehive scenario with the advent of human level AI. I think the reverse might happen.
Now you've gotten me thinking, because we're both only Amiga, bro. Like we're a different breed of cat. Like Amiga changes you. It's real. So you got to think about the Amiga generation. That's like technology worked with us to expand us. And then you look at the Facebook generation, where people can't remember phone numbers anymore. So I think the deal is that certain kinds of technology was designed and can be designed to expand us, and certain kinds of corporate technology can be used to make you rely on that corporate technology in order to not rely on yourself, which might limit you.
Right.
That's not AI's fault.
I feel Facebook and this social media is crippling even though, you know what, I should be an expert in using the internet tools. I've used them for so long. Anyone can fall for those psychological tricks and get lost in this ocean of distractions. So I didn't see this question about Socrates. Can you show it again?
Yeah, I will. I was also going to say, I think when you're saying, because I think you're mixing up two words, thalamus and Themis, because Themis is the goddess of the she's a Titaness. Is that what you're referring to, is the Titaness? Because the brain is the thalamus, I believe. I'm not familiar with the Themis.
Right.
Is that what you're saying?
Right. Yeah. So that's in the brain we have the thalamus, right? All right. Okay. So right. So could technology be? I mean, can we design AI that will push humans in a better direction? That's a great question to ask. It's because. Right, we're about to speak about GPT-3, right? Now, you could use GPT-3 in a number of ways. Like, you could use it to, I think, well, inspire students, or to sell kids really unnecessary items. Like, you could use it for marketing, or brainwashing people into really harmful political opinions, right?
I'm muted. Yeah, so that's the thing also about GPT-3, going from OpenAI to Microsoft, closing AI. What do you feel about free software, closed software, classified software? What do you think about all that?
Yeah, it's I'm kind of mixed on that, because I've been releasing a lot of free software lately, because I'm not sure how it will be used, but I think free software has helped the deep learning field a lot. So it's obviously very useful. It helps advanced science. So when there is this technical field, it can make use of this openness very well. It's actually quite useful.
What about problems with openness? What are the reasons we stay closed, and why are there still classified datas and informations?
Right. It's a lot of technology is proprietary technology because it gives corporations an edge, commercial advantage. So that's more or less the most important reason for keeping software or technology closed. But some technology should probably be free software, and some technology should be known by everyone because it's critical. Say like the voting machines, right? Or security systems, or maybe operating systems. If you don't know what's in it, you can't really trust it. And so that sort of thing, like the technology that makes platforms should at least be free, and that might include AI, because in order to be able to trust an AI, I think it would help to know how it works. So it's like
Unicorn says that in order to have some, you need to have some proprietary software to attract talent.
No, not really. Like a lot of startups just use free software nowadays. Like most is free software, but I mean, some companies are and projects are built entirely on free software, so that's possible. But once you incorporate, I think they usually expect you to have some proprietary software, right? Even if built on free software.
Even OpenCog, I mean, like you can, OpenCog, it's available, right, if you can figure it out.
They say it's free software, but I don't know. Maybe the real version is closed source. We're not sure.
Wink. Yeah, totally. I don't know. Yeah. Yeah. Well, I mean, so that gets you into the other thing, is the scary competitive edge use of technology, and where the money comes from. I'm not going to mention Schmepstein, but like, you know how it goes, where we get some money from something and then we have to use it to make something evil instead of good. what do you think's going on with that in military use of artificial intelligence versus financial Wall Street use of artificial intelligence versus medically and positive? What do you think is the good and evil in all this?
Well, there was this like I just have it on my desktop. They say a paper by Google on using.
You might hold on. Do a reload. Do a reload real quick before the glitch. Reload the page.
Okay.
I have confidence in sunshine. I have confidence in rain. I have confidence in True Life. Thank you, True Life. There we go. Oh, and while you were gone, True Life had another thing. In Plato's dialogue, Phaedrus, Socrates tells a parable. A famous old god called Thuth is being questioned by another god, Thamus, king of Egypt, about the many arts he has invented. Okay. We can look into this more. This is awesome. But yeah, sorry, you were about to say.
Right. So in healthcare, people are trying to retain an edge, obviously. So it looks like a lot of stuff is already proprietary, like Google stuff. And so they published a paper, but they didn't publish the details. And scientists wrote a letter to Nature about it because they found it is not reproducible.
Yeah, that's huge. So if we can't reproduce the results, is it science? I know you were saying I don't want to have to define science, but I'm going to make you do it anyway. Do you want to talk about good science for a second, please?
Right, of course. Good science should, of course, be reproducible. It should be very clear. Science is about predicting. So it must be able to show you the findings very clearly, and this includes all experimental setups, all the details, so that other researchers can replicate those results. And it's about discovery of course, new information, discovery of the most general laws in nature. This is sometimes tangled with commercial interests, and that's when some funny stuff happens, like say, I don't know, big pharma or well, as in Google's example of using AI for healthcare. They said military and finance. Yeah, those are examples of proprietary use of AI, definitely. Military DARPA has had a lot of AI projects. Most of those projects are classified. So they've shown some stuff, and actually the most successful AGI systems have been built for those projects, and the details are not really very public. I think some of it is, and some of it overlaps with my research. And okay, so this is funny. I got tailed by this guy who probably worked for DARPA, and they're tracking the progress like very closely. They're tracking AGI researchers, and it was funny, you know. So they want to have the best AI in the world for sure.
So that must be very flattering when the government like is spying on you. You're like, oh,
right.
nice.
It's
Me, just a little me.
Yeah, like it's kind of scary actually, because it was not very it was very awkward when I realized that. So because they also worked a lot on stealing some of my research, so that's the not funny part.
Such is life.
That's the first time. Right. So I mean, they are very interested in keeping the edge, strategic advantage, or whatever you want to call it, on general AI, because as you know, I think that's an ongoing, you know, DARPA focus actually, and they haven't disclosed much about it, but they might have built very powerful flight automation systems and such, even in early 1980s. You know, I've heard stories like that.
even looking at what Russia's doing in the Silicon Forest is just insane with the amount of data neural processing and deep learning that they're able to do. For, I mean, it's there must have been more Amigas in Russia because like all of I'm serious, like the amount of pattern recognition that they're doing, and if you've seen like Prisma and just these free apps that the Russians are putting out so they can fund their AI research, like they're ahead of the game in a lot of ways as well, but they're almost 100% financed by their military because it's quasi-military run, you know.
Right. I haven't really looked much, so I can't say, but I trust you. So I'll take a look if you send me some links later.
Definitely. Well, okay. So in terms of oh, you were to say, go ahead.
Right. So yeah, and so the next 100 years, like what after we start automating some labor, what would happen? Like in what way our lives would change or world would change? I predicted that we could automate a lot of maintenance tasks, like in the Matrix. Like, I mean, AI could look after things like agriculture. That would be very helpful. And it could even engage in this, gigantic geoengineering projects that we will probably need to survive. And so this AI might actually save the world.
And reducing entropy. I mean, I have friends who are working on glider drones. They're like they just literally set off a foam plane that flies over fields, but it has a little propeller on it and it keeps flying for like 36 hours. And the reason is so they can look with a camera to find places that the water is not watered appropriately, and then it'll specifically target to water those places. So they've reduced the need of just watering everything. And so they're using 20% of the water that they used to use for farming. And that's a big deal when you're doing monocropping or 50 or 100 miles.
Right, absolutely right. So it can lead to efficiency gains or capability gains. It's just as important for that, but it opens up so many possibilities, of course. Like you can automate so many tasks that were just impossible before, right? Like you can do this, like really fine inspection and manipulation of plants, trees, everything.
That's a beautiful future. So what about Sophia? Is there a reason? What does she represent? How far along is she? What do you think about? Is she pretty? Do you like her? I think she's pretty.
Yeah. Okay. Like, I think she's pretty because she's been modeled after one of the most beautiful actresses in the world, and Hanson's wife. I think so. It's something like that. It's she has a beautiful face, and she can. I mean, the point of Sophia was to show that the robot can cross the uncanny valley, right? And show human emotions, gestures without spooking people. So it can do that perfectly, I think. It's a good demonstration. As far as the AI goes, like, I mean, the interviews, most of it, I think, was just kind of an interactive scripting. But the important thing there is to associate all those gestures, like smiling and frowning, with the speech and the head motion, etc. And so I think they did that. After that, I'm not quite sure what they did. They told us that they use a version of OpenCog for driving the conversation. I believe them, but I haven't really seen the technical details of that, so I can't really comment. So I mean, it's potentially be very powerful, of course. Like what they want to do is to connect the Sophia robot, the interface, to the Singularity net, where a kind of decentralized AI will run, and so this will potentially be used as something like information retrieval system, or say it could run. It already runs the Google search kind of queries, and vocalizes them. It can do that sort of stuff, but more intelligent assistant-like stuff. And that could be pretty handy, you know. Like it could evolve towards this very versatile, you know, a human replacements robot. He can use a bartender or something. It would have many uses. Like they use it for, you know, PR, right? So it's great for PR. Like everyone wants to see a cool robot, and I think they took it on tour, and so they had a few instances of the robot, right? And they use it for appearances. It's also making use of the celebrity status of Sophia, but that's a cool trick. But in actual use, I mean, you could see it becoming a hotel reception in this luxurious Dubai hotel, right? So it's just a thing for it.
Yeah, but you're essentially imagining that. Well, I guess the point is that Sophia, a big part of Sophia is just the mechanical human responses, and
Right.
that's separate from the Singularity AGI kind of concept.
Right. But they're trying to merge these, like, you know, they're trying to make a version of OpenCog that runs well on the Singularity Net environment, and then connect this with Sophia. It says that was their, you know, selling proposition, so that they're trying to achieve it. It's a great goal, you know. It's just the kind of thing that people want to see. So I wish them all the success, of course.
Well, okay. So also in terms of your projects right now that you're working on, do you want to describe where you're headed and how people can find out more about it?
Right. So I'm working on what's called the neurosymbolic architecture. It's neurosymbolic AGI, which means that it combines its popular deep learning methods with symbolic computation or symbolic AI methods, like writing small Lisp programs to solve problems. So it can do things like decision trees, or say sorting a list of numbers with a neural network method, like recognizing an image. And the really interesting thing about this architecture is that it expands over Solmov's earlier architecture called Alpha. And Alpha had this idea that a very important principle of intelligence is diversity. And my Omega architecture tries to apply this principle of diversity to the fullest. So I propose combining something like 8 to 12 representation languages and about like 50 to 100 machine learning models in this grand unified architecture. I call this an AI unification architecture. So it unifies a lot of methods, approaches in AI using some common representations and algorithms. The algorithms are called the AI kernel. So this is like a stack of general purpose machine learning algorithms, incorporating stuff like transfer learning and unsupervised learning and meta learning to search through this very large space of models and find the right deep learning or symbolic solution for your problem. The interesting thing is some observation made by Minsky. He noticed that for every problem, there's an optimal representation method, right? So this is very close to what is now known as very advanced field of representation learning in deep learning. So that's basically teaching a neural network to represent a data structure, a model, or a function or process. It uses the capability of RNNs or deep nets to learn pretty much anything, right? So that's one of the approaches I'm trying to use over and over again in this system. So the ability to represent things using this very wide range of representation languages and built-in working machine learning models is pretty much the approach I'm trying. And this will give the system the ability to combine neural and symbolic computations at the very basic. But the idea is that this can be done in a seamless manner. So the system architecture is trying to imitate what a machine learning researcher does. Like we pick some components, we pick some basic representations and methods to make a machine learning architecture. So this system is intended to deal with all the intricacies of this process. So it can solve machine learning or data science tasks that at least beginner level data scientists can. Another interesting thing is that it automates transfer learning, and it tries to build up this composite knowledge base of everything that it has encountered so far, and that improves its future performance. It also does things like self-improvement. So in its spare time, it reflects on its previous solutions and tries to synthesize new methods or analyze its previous performance. So it's kind of conscious. It's not conscious like human, but it has some self-reflection, and it's also going to have a dialogue system to interact using language, and intelligent agents in it. It's pretty expensive. Like I would like to explain it all, but the gist of it is that I'm trying to incorporate the best practices in both deep learning and symbolic kind of general purpose machine learning into a single unified architecture. That's why I called it an AI unification architecture. That term was first, I think, used by Alexei Potapov. I really liked it, so I hate to use it. It's of course there are a lot of tricks. This kind of system is supposed to be very good at program synthesis. So it can potentially solve programming problems, general programming problems, or optimization problems in a wide range of scenarios. So that can be used eventually to automate very complex things like programming and maybe other engineering tasks even. I mean, deep learning has already been used for this. As this was one of the things I predicted, and I'm kind of proud of it, is they are using it to analyze things like particle collider data, LHC data, astrophysics data, to control fusion reactors, and you can use it to solve physics problems and not just pattern recognition problems. So it's all these complex scientific computing problems. If you had the right meta learning architecture to do this, it will be very useful. So another important property of Omega is that it's open-ended. So that means it's not limited by what's initially given to it. It can expand its repertoire of machine learning methods and models and solutions. As it works, it continually tries to discover, invent new stuff, and the useful ones it remembers and keeps. That's like the basic design principle. of the architecture. It's supposed to be very powerful, but I have to do a lot of experiments. The nice thing about neurosymbolic architectures is that they may provide an easy way to interpretability or explainability in AI. So it might be possible. I don't exactly know how easy this will be, but deep learning architectures have an interpretability problem. They're black box systems. So yeah, as I said, this can generate a lot of existing deep learning architectures, and even discovered novel deep learning architecture. So it has this representation capability to do that. It's imagination capable. But on top of that, it can also generate these hybrid neurosymbolic architectures, and these can help to construct interpretable, explainable models. So it might be able to automate a lot of that stuff. So I think the crux of Omega architecture is that I try to automate as much as possible using techniques like meta-learning, unsupervised learning, autonomy, as self-reflection, self-improvement, using as little data as possible, and automating it.
Really quickly, can you explain a bit for why, and I think it should be self-obvious, but why it's better for something to figure something out itself rather than to rely on data that we've taught it?
Right. Data annotation is really hard. Preparing is really costly. So if you make great use of unsupervised learning and self-supervised or semi-supervised learning methods, this helps in the way of using less data, fewer data points, and less need for annotations. So eventually this sort of system can fill in the gaps better, kind of like what a human data scientist does, right? Like you have a sense that perhaps this problem could be solved by this paper, and hey, they use this, like, okay, well, they use this CNN with convolutional neural network with complex values in this paper, and this worked really well for it. Oh yeah, I kind of vaguely remember this, so I'll use this. This kind of thinking that it does this at the model level, but also at the data level, it can do this. So it can do things like, okay, like I solved a similar problem in the past, and I figured out like these labels for this problem. So maybe I can, I can reuse them, and this will improve my accuracy. And then so I can first cluster this data, and this helps improve the accuracy and this sort of thing. These methods usually require less labeling, less human intervention. So that's kind of important. But it also, you can add interpretability on top. So it's like using this very.
Wait, can you? I think you need to reload. You might need to reload one more time. Sorry to say.
Right. I'm sorry. Like I'm sorry if yeah.
No, it's just the internet thing. Actually, before you do, let me read this comment, because this is one of my favorite comments so far. Brittany says she feels silly for thinking tech people were so super serious. He's lighthearted, and I want to be pals with this guy. The greatest guest. I want to reiterate that if anyone was going to make AI, I think it should be a person that's having as good of a person as you, and I appreciate that you're the guy who's doing it. Like, because you're trying to make, if someone as good as you tries to make AI, hopefully AI will turn out better just because of that. I appreciate that a lot.
Thank you. Like, I strongly believe that we should never forget what end goal is. And the end goal is, of course, expanding our knowledge experience, right? that's what we want to use AI for, and we, of course, we want to make the world a better place. But the most important thing for me was realizing Solomonov's dream, and he was talking about this scientist assistant, right? So, well, some of us scientists can't afford assistants, and some of us don't have as many assistants as we would like to have. It's a big limitation for doing great science. Think of it like you have a big computer, and now you have 100 virtual assistants, scientist assistants that work on different tasks. Like one is you want to build a rocket and you want to go to the moon, but you need like 100 engineers to do it, to do the design, to do the detailed design, right? Engineering design. One is going to work on materials, one is going to work on the engine, and one is going to work on like aerodynamics, and this kind of AI can do it all. That's what I hate in mind.
A bunch of narrow AIs together is kind of like it's a team. It's great.
Right. So the Omega architecture is well suited to this kind of task. It can specialize and learn in a domain, and gain expertise in that domain and get better. There are instances of this in the literature, in the deep learning literature now. There's meta learning. You've probably heard of AutoML, similar approaches, really. So the story done is, and they've gotten real fantastic, brilliant results with AutoML. So this is just an alternative approach to the same problem. I started designing it before, but it doesn't change that. There are many competing methods for right now. So I think this, meta learning approach is going to help a lot, and it relieves some human dependency. So the design principle is, if I remove as much human dependency, like human programming dependency, the better it will be. I express this as the intelligence of a system is limited by the amount of system code that the system cannot reprogram. So the idea here is to use machine learning to rewrite, to reprogram as much of itself as possible. So the bulk of the system is very adaptable. It can replace, improve any part of itself. It is open-ended, so it can invent new models and just add it to its library of models. It can expand itself, kind of like how a human scientist works. So I was trying to replicate that, that capability of how the human scientist is so open-ended, and can accumulate so much expertise. Everything in my design depends on getting the transfer learning components right. So there have been great studies on that. Actually, the studies DARPA researchers have done are just very similar to my designs. It's they figured out some stuff. So it's we're now using also deep learning to do that. So we can use deep learning to store these complex patterns nowadays. We couldn't do that before, right? So we use it for image processing, other process, but now we can do complex stuff like graphs and other stuff. So so now we can store all sorts of patterns, and now it's like we can use deep learning for more things. And now about GPT-3, I think you have questions about that too, right?
Yeah, a lot of people do. It's not just me. I guess why don't you just start by explaining a bit about the difference between GPT-2 and GPT-3. I mean, and also why it's closed source. I don't know. Just go into it. Just go for it.
Right. Well, yeah, okay. It takes a lot of time to train that model, a transformer model. So it's expensive to train it. So the running the model, you know, the model parameters, it's an obvious proprietary IP model, because it's so costly to train and to run. So you can just market it as a service. So that's the reason, and it could be. It's said that similar performance can be achieved with much fewer parameters, of course. So that's possible, but
What was GPT-2 is like 10? I forget what it was, and now it's like 175 billion. You know, not quite, but you know, I mean, it is.
Yeah, it is like it takes a good deal of compute to train, so that's like the bottleneck. But of course, this will you know, this will be cheaper with time, right? But then, I mean, until it becomes like commercially cheap, it's they can just sell this kind of service. As like GPT-3 does a lot, but as other researchers have pointed out, it is of course limited. It's not really very good at semantics department. It only seems to understand things because it knows so much syntactic context, right? It doesn't really know stuff, but it's kind of.
It's like a kid that can kind of pretend to be in the conversation. It's still not quite Turing.
Yeah. You explained it perfectly. It's well, it's how we first, you know, try to talk about new subjects. Actually, it's we don't fully understand it first, but we just, I think, catch speech patterns, right? So
intonation and flow, cadence. Yeah, it learns all that before it learns the meaning of the words.
Right. So it doesn't really fully grasp the meaning of things, but it learns like how to use them in context. It learns how to write the right expressions. So
it learns how to be like it can recognize its response, the response of others to its response is being positive, and so It's like, oh, you liked what I said, good, basically.
Right. So it's like a very clever syntactic model. It's so that leads to some semantics, but not full. It's not all of the meaning is not encoded in that relation it's learning, right? So a machine that actually learns the meaning of words, the actual meaning, the intelligent kind of meaning, will take a lot more parameters. Obviously, but it's still very impressive. Like especially the text generation thing, the prompt thing. I've seen some stuff that they made, and you know, like if you try enough times, you get very interesting stuff because it's been, you know, fed so much text, so much human ingenuity, right? Like it contains a lot of human creativity. That's how to view it.
Man, I can't believe it. We're about 2 hours into this thing, and I feel like we're just barely scratching the surface. I have to please someday soon. You're gonna have to come back, and we're gonna have to go much deeper into Marvin Minsky and everything else.
Right?
Is there more?
Thank you, man.
Dude, no, you're the greatest, man. I love that you're doing this, and like that you're changing the world in such a great way. Is there anything you want to say, like ways that people can contact you, ways they can help support you, and like ways they can keep looking into what you're doing?
Right. It's my blog is at log.examachine.net. So it's they can see some of my stuff.
I'll make a little banner for it really quickly. There we go. Adding banner. Bam, guys, check out this. This is awesome.
Right, so, you can read some of my essays there, and contact information. I try to, publicly visible. I don't know if that's a good idea. Like I've always believed in connecting with people. Sometimes that doesn't work out.
Right. Yeah. No, this is good. This is all they need right here. And if they can send you money somehow, that was my main thought.
Thanks a lot for your interest, man, and having me here. Like it's been a really fun conversation. It's so I'm hoping to return and we'll talk about some more cool AI stuff.
Definitely. And remind me to send you that video I have of Marvin Minsky playing the piano, because like he's awesome. And like so yeah, this has been really exciting. I feel like we just watched the Avatar sequel or something. It's just so much information we went through.
Thanks, man. Like it's really been great to to be able to tell all this stuff. Like it's been kind of random, but I hope I'm glad you enjoyed it. Right?
Yeah, it's a bit 101 for some people that haven't really thought about why. I mean, there's a lot of people that are really afraid of technology and the future. They're afraid of you and me. They're afraid of what we're trying to do. And I think that this helped in a huge way. And I hope that we can continue to talk about the solutions and the problems that are coming in the future. But for now, man, just thanks so much for coming on the show. It was really awesome, Eray. I really appreciate it.
You're welcome. And hello to everyone and goodbye. I'll see you soon.
Yeah, guys, you've been watching Recent Tartarians with Eray and Exertus, and we'll do it again. Peace.